Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, my dear students. I am Mr. Muhammad Said, and this is the third and the last part of this lesson, exponential functions. And this is the hard one, which contains some other, let's say, intervention from other lessons. I mean, some questions are connecting the exponential functions with something else, some other lessons. And if you want to build your, let's say, your skills, and you master your skills, you need to work through the 4 levels. I mean, the starting level is something called fluency. So you are fluent in something. You're good. You practice and answer many questions in this way. Like what? For example, when I ask you to get that 20, let's say 50% of 40. You are fluent and you write 50% means 50 over 100 as the teacher told you. Of means multiply and then 40 and then cross the 0 with the 0, the other 0 with the other 0, and 5 times 4 is 20. Okay, you are good now because you are fluent. But if you go to the second level, which is understanding, the understanding level is where the mind works better than the hands. I mean, 50% is half. What is half of 40? It's 20. You can get it by just thinking about the question. Think deeper and wait for your hands to give your mind a good opportunity to work without using the skills you have. So the understanding is very important part. Then you go through that third level, which is called the application, and where you apply these ideas in the real life. For example, the trousers are $180 and we have 20% discount. Now you apply these ideas, but you need to understand because the question asks you for something maybe other than what you are looking for. Maybe the question says, what is the discount in dollars? Maybe the question says, what is the selling price? And so on. So you need to apply what the ideas we studied in the school in the real life. That's the application. And then the fourth level is called the reasoning. And reasoning is something maybe a higher level, the highest level. Reasoning is when I ask you, for example, is 10% discount followed by another 10% discount the same as 20% discount once in one time? Are they the same? For example, if you have a laptop which costs $1,000, does it give the same amount when you have 2 discounts followed by each other to this amount, or with one discount of 20%? Are these the same? Of course, they are not the same. When you understand this, when you get this level, which is reasoning, or applying the logic in your mind and think deeply with the question, and you cannot get this level without passing through the other 3 levels. This is why you have to learn. You have to learn using the steps. In order to get to the highest level, you need to pass through these steps like the stairs. You can't get to this step here without passing through all of these. So that's what the course should be. And in this lesson, the hard one, we explore the fourth and the third level together. We have some questions that are related to the reasoning, and some of them also in application. Question number 1. P of t is equal to 290 times 1.04 to the power of 4 over 6t. The function p models the population in thousands of a certain city t years after 2005. According to the model, the population is predicted to increase by n% every 18 months. What is the value of n? Of course, if you just have a look at n% increase, this should be the same as this number. But you have to make sure that this is the same as this. Because if they are not the same, the answer would not be the same. I mean, if you are sure that this number is the same as 18 months, you can just freely say increase by n% means 1 plus n%. It's the same as the number that's between the parentheses, as we said before, 1.04, and use the calculator to get the value of n, like this. 1 plus n% means you can just write 1 plus x%, and x is like this, alpha with this button right here. Percent is shift with the open one, equals alpha calc, and then write 1.04 and shift calc, and you get the answer as 4. So the answer is 4. Letter C, it's okay, but if you are sure that this is the same as this, how can we make sure that, because this is also a kind of question that we can encounter sometimes. So 4/6 years, is it the same as 18 months? Yeah, because the word every here, as we said before in the very beginning of the lesson, we said every is always, when you write y is equal to a times b to the power of x over something, let's say c, this c is with the word every. So every is the answer. Every something, this thing should be below the t. But how can we transfer this to be below t? If you want to do that, to apply the word every, you need to write it like this. T over, if you want to move this down, make it the reciprocal. 6/4 instead of 4/6. So now you can say this means every 6/4 year. Every 6/4 year, which means every 6/4, and the year is 12 months. 12 months. Now we can simplify this. Divide by 4 to be 1, divide by 4 to be 3. So 6 times 3 is 18 months. So now every 6/4 years means every 18 months, which is the same. So now we are talking about the same. So we are not worried about this. 1.04 is the same as 1.1 plus n%, which gives us n as 4. And that's how to reach the answer. Question number 2, the functions f and g are defined by the given equations where x is greater than or equal to 0. Which of the following equations displays as a constant or coefficient the maximum value of the function it defines by this? Remember that the exponential function in the real numbers does not have a maximum or minimum. It does not have. But if we have a limit and we cut the graph at this point, we already have a minimum or maximum. How can we explore that? Let's look at this graph, maybe both of them on Desmos, to see how can we graph them. If you look at this graph on Desmos here, 33, 0.4, let's try the first one, 33, 0.4 to the power of x plus 3. Let's go up here and write the exponent, x plus 3. But between the parentheses, as you know, x plus 3. And we get this graph right here, okay? And the second one is 33, 0.16, 0.4. To the power of what? To the power of x minus 2. So the exponent is x minus 2 inside the parentheses. And now we have this second graph. Now we have the third constraint, which is this. X is greater than or equal to 0. X is greater than or equal to 0. And here we have this part. This means that we need to cut this graph in this area only. We don't need to look at the left one. So this point is the maximum of the graph when you are inside this area. That's the meaning of this. Okay, but forever it's not having a limit. Does not have a maximum or minimum as well. And we understand the minimum later, because don't say the 0 is a minimum. It's not a minimum because this line does not touch the 0. Okay, so this now is a maximum, but look at this number, 2.112. Do you have this number here? So here when we look at the red one, the red line here, the red graph, we have 33. 33 given here, it's given here also. So this function is the correct answer. But this one, the black line, this is color, the color is black here. If you go down here, you find the number, which is 2.112 is not given in the function. So the function, this one, gives us the maximum point of 33, which makes it the correct one. So this one is the correct answer that contains x minus 2. So letter number 2 is the correct one, so we choose 2 only. You can also use the calculator, the standard calculator, to write the answer, to substitute, and instead of x, to write 3 in both of them. Write 0. So here we can say 33, and then 0.4. The exponent is 0 plus 3, which is 3. You can just write 3, and the answer here is not inside the question. This number in the calculator, not in the question, so in the equation. So I mean, this is not correct. If you try the second one, 33, and this number is 0.16, and then we have another number, which is 0.4, and x minus 2 means 0 minus 2, which is negative 2. Let's make this here. The answer is 33. The answer on the calculator is the same as the coefficient, which makes the coefficient appearing in the equation. So number 2 only is the answer. And then question number 3, we have this. The same idea, maybe. We need the coefficient or a constant to be displayed. Displayed means appearing in the answers. But when in the y-intercept. Y-intercept is always 0 and something. So R and S means 0 and something, because this is y-intercept. So replace x by 0. 576 to the power of 2 times 0 plus 2 makes it 576. 2 times 0 is 0. 0 plus 2 is 2. Let's calculate this. 576 to the second power. We have this number. Yeah. 331776. And look at the options. Which one contains this number just appearing in the equation without calculating? Displays. It's obviously letter A. This number is appearing here. So that's the answer. So the equation gives us the y-intercept of this number on the calculator. Which of the following equivalent equation? Equivalent means are the same. Displays the value S. The value of S, which is the y-intercept, as a coefficient or a constant. It's a coefficient now. So just choose this. None of these contain the same number, B, C, or D. Question number 4. A company opens an account with an initial balance of this. Initial is always the A. When I write y is equal to A times B to the x, A is the initial. So we can replace A now with this number. Y is equal to 36,100. 0.00, b to the x power. The account earns interest and no additional deposits or withdrawals are made. The account balance is given by an exponential function a, where a of t is the account balance in dollars t years after the account is opened. The account after 13 years is this. Which of the given equations could define a? So now we can just look at this equation right here and search for one of them to maybe eliminate 2 of the options. 36,100 should be in the beginning. So here, this may be the answer, or maybe this one. So we can just now eliminate B and D because they contain different numbers, okay? So now we have this, A or D. But how can we distinguish them? Look at the number. The easiest way is to look at this number and this number. What happened? The number 36,000 increased. Increased means the number inside the parentheses is more than 1. 1.05, not 0.05. 0.05 means decreased. And 1 point something is increased. So which one is increasing? Letter A. That's it. Without even calculating, just distinguish them by this way. Question number 5, we have this function here, and we have g of x is f of x plus 2. This is g, and all of these are g, which means all of these are, one of them is representing this one. But how can we write g of x here? Because g is connected to f. So g of x is equal to f of x plus 2. So just replace x by x plus 2. Instead of x, we write x plus 2, which means this should be 9 times 4 to the power of x plus 2. How can we get the one of these that is identical with this? We can graph. We can graph this one and graph all of these to compare. Let's graph this one first. 9 times 4 to the x plus 2. 9 into 4 to the power of x plus 2, but don't forget to write the pair of parentheses, x plus 2. This is our first graph, okay? First graph here. Let's zoom in here, and this is our graph. Let's find which one is the same as this. Let's write them all. 18, 4 to the x, 18, 4 to the power of x. Here, they are not the same. Look, this blue one is not the same as our green one. Remember, our graph is the green one. This is not the same. So this is not the correct answer. 144, 4 to the x. So instead of this, we write 144. Yeah, we get the same now, the same graph. So look at this. This is green. If you click on this one, you get the same graph, but purple, which makes it the same function. If you try anything else, you will not find the same. 18, 8 to the power of x, for example. 18, 8 to the x power is something different. Also, 81, 16 to the x. 81 here, 16 to the x, you get another one, not the same as our green one. But if you graph letter B, you get the same answer. That's the easiest way to work through this kind of questions. Number 6, the functions f and g are defined by this, the same idea we studied before. We can also now, we tried answering the question on Desmos before. Let's try to answer this question manually. I mean, using the calculator, replacing x by 0 in all of these. And when the number given is the same as in the question, we choose it because the constant or coefficient should be displayed. So let's write now x as 0. So now we have this one will be 18. 1.25 to the power of 0 plus 41. So any number to the power of 0 is equal to 1. So 1 times 18 is 18. 18 plus 41 will be 59. Is this 59 given here, appearing here? No. So this is not correct. The second one, 9, 0.73 to the power of x, and x here is 0. So any number power 0 is equal to 1. 1 times 9 is 9. Is 9 displayed here? Yeah. So we choose the number 2. That's it. So 2 only is the answer. Question number 7. We have this. We explained this, the same idea before, but let's make it again in order for you to understand it more and more. We write h here. H is equal to f of x minus 4. And instead of x here, we write x minus 4. 272. 2 to the x minus 4. Let's write it. Let's graph it on the Desmos graphing calculator. 272 to the x minus 4. 272 into 2 to the power of x minus 4, like this. This is our graph. Okay. And then we write all of these, but one by one. 17 2 to the x. Let's write it here, 17 2 to the x power. Yeah, we get the same answer. So that's it. Look, black. Our black graph is the same as this one, which is blue, which is red. So we choose letter A directly without even exploring any of these. Question number 8. We have a table here, and the table contains many values. And the question says, a culture of bacteria is growing at an exponential rate, as shown in the table above. At this rate, on which day will the number of bacteria per millimeters reach this? So reach this means the number of bacteria, this is y, because the number of bacteria here is y. And on which day means x. We need the value x, which means a question. We need to find the value of x. But if we want to get this, we need to get an equation of this. Desmos is a very helpful tool that gives us the equation. Let's make it together. 1, 2, 3. Let's make a table. Add a table here. 1, enter, 2, enter, gives us 3, and then we go up to write the numbers. 2.5 times 10 to the 5th. 2.5 times 10 to the 5th power. Then 5.0 means 5 times 10 to the 5. And then the third one, 1 times 10 to the 6th power. So 10 to the 6th power, because 1 times anything is the same thing. these are the values of the table. You just click on here and choose exponential regression, and you get this number, this function y. Let's clarify it. Y, and this graph also is as shown here. Y is equal to 125,000 times 2 to the x. Let's write it here. Now we need to get this. This is as y, because the number of bacteria reached this amount. Number of bacteria is y, so replace this in the y value. So 5.12 times 10 to the 8th power is equal to 125, 3 zeros, 2 to the power of x. Don't write this on the calculator. It will be confusing. Maybe the calculator gives you an error, or maybe it cannot solve it. So we can simplify it a little bit. Divide by 125,000 in both of these two sides gives us 2 to the x is equal to this number. This number can be only written on the calculator. Just make a fraction bar. 5.12 times 10 to the 8th power over 125, 3 zeros. And this is 4,096. How can we get x here? There is a very easy method on the calculator. Remember this. How can we get the answer? We can write the number 4,096 equals, in order to drop it from here down here, and then click shift and the comma button, like this. So 2 to the power of 12. So this 2 to the x is the same as 2 to the power of 12. And this is a very easy and helpful method. So x is equal to 12 because the base is the same as the base. So 12 day is the answer. So here, how can we use this again? For example, if you know that 27 is 3 to the power of 3, right? So we can write 27 equals, and then shift with this number. It gives you that exponential method of expressing the number. You know that 100 is 10 to the power of 2, right? 100 equals, and then shift this. Maybe, yeah, this is the, let's say, the prime factorization, because 10 to the power of 2 or 2 to the power of 2 times 5 to the power of 2. This is also helpful in some cases. But if you are working with 81, what about 81? You know, 81 is 3 to the power of 4. So equals first, and then like this, you get that 3 to the power of 4, and so on. So we use the same number, the same method to get 2 to the power of 12. So now 12 is the same as x. X here is the number of days, so the 12th day is our answer. Question number 9. P is equal to P naught into 1 plus R to the power of Y. The population P of a certain city Y years after the last census is made by the equation above, where R is a constant and P naught is the population where Y is equal to 0. If during this time the population of the city decreased by a fixed percent each year, which of the following must be true? Decreases means 1 minus something, not 1 plus something. 1 minus. What does this mean? This means the R must be negative number. 1 plus something negative, like negative 0.5, is the same as 1 minus 0.5, which makes decreasing. So whenever the word is decreasing given here, decreases means this number should be less than 1. How can this number be less than 1? 1 plus R should be less than 1 because the word decreases. Now we can move the 1 to have R less than 1 minus 1, which is 0. R is less than 0, but to where? Less than 0 is given here. But of course, it's not exceeding negative 1. So the only one given R is less than 0 is letter B. Look, R is less than 0 is given here. This R is greater than 0, which is not correct. So R is between 0 and negative 1, and that's, of course, a logic. Number 10. Here, which of the following functions have or has a minimum value at x is equal to 3? Guys, in this question, do you have any inequality? No. So we don't have a minimum or maximum. Guys, listen to me. When you have a graph like this graph in anything here on Desmos, let's look at this graph, for example, this one. Does this graph, without giving an inequality, have any maximum or minimum? The maximum value, where is the maximum? We don't have a maximum, even if you move through the line till tomorrow. You'll not find anything. What is the minimum? Some people say the minimum is this line. No, because the graph does not touch this line. Look, it moves beside it, but it can never touch it. This makes it not a minimum. So we have no minimum. Not minimum, we have no minimum, we have also no maximum in any exponential function. But if you have an inequality, that makes something logic to have a minimum or maximum. For example, if you have x is less than or equal to, or less than or equal to negative 16. Look, now we are talking about this part. This point is the maximum of the graph inside this area. So when you have an inequality, there is a logic behind that. But if you don't have an inequality here, we cannot have a minimum or maximum for any exponential function. Neither. That's the answer. Question number 11. A scientist initially measures 12,000 bacteria in a growth medium. 4 hours later, the scientist measured 24,000 bacteria. Assuming exponential growth, the formula is this. This formula is our exponential function. P is equal to C 2 to the RT. And here, this is initially, which makes C equal this number. So P is equal to 12,000 times 2 to the power of RT. And then it says after 4 hours, which makes T 4, because T here is the number of hours, the result is 24,000. So replace P by 24,000. And T with 4. So 4 times R is 4R. Now we can simplify this by dividing by 12,000. Cancel these out. 2 to the power of 4R is equal to this. This is equal to 2 because 3 zeros are cancelled and 24 divided by 12 is 2. And of course, if it's 2, it should be 2 to the power 1, 2 to the power of 1. Because the base is the same as the base, the exponents are the same. 4R is equal to 1. 4R is equal to 1. We divide by 4 to get R is 1 over 4, letter E. And then question number 12 is repeated. We said it before. Number 13. Question number 13, we have a table. The table above gives the values of the function f, and which of the following define the function. As I told you, you can use the Desmos to write this table. 5, and this is easy to remember. 5, 5 over 2, 5 over 4, 5 over 8, 0, 1, 2, 3. Just explain, just put them on the table here, at the table. 0 first, 0, 1, 2, 3. And then we write here 5, 5 over 2, 5 over 4, and 5 over 8. And then we can get this exponential regression, and we get the function 5 times 0.5 to the power of x. I think it's already graphed here. Yeah, you can see the graph, as you can see here. Our graph now is green, okay? Let's draw all of these and see which one is the same as our green one. 5 times 2 to the x plus 1. Let's write it here. 5 into 2 to the power of x plus 1 inside the parentheses, x plus 1. This is not the same. Look, it's not the same. This is decreasing, our graph is decreasing, and this one is increasing. So this is not the same. 2 to the x only, of course, would be the same thing. I mean, it's increasing also, which is not the same answer. 2 to the negative and x plus 1. Negative here, and open the parentheses and write x plus 1 like this. This is not the same. Even if you close the parentheses, not the same as our graph, which is the green one. So let's check the last one. So all of these are incorrect. The last one, of course, is the answer to the negative 2 to the power of negative x. So we remove this one here and this parenthesis negative x, which is the same. Look at this one. If you click here on our graph equation, green equation, here we have the green equation here. This is the green one, and this is the blue one. Let's drop this down. Yeah, they both became the same color, which is okay. So the answer, which is identical to our graph, is letter D. Question number 14 is the last one. And we had this idea before. I mean, I repeat this idea in order for you to understand it and master it, because repetition is very important in math. This is an inequality. And this is, so now we can have a minimum or maximum, no problem, because we have an inequality. We can graph it on Desmos, but now we can try to answer it without graphing. You can just substitute. And instead of x, we write 0. So 18, 1.16, 1.4 to the power of 0 plus 2, which is 2. If you put this on the calculator and you get the answer, this answer on the calculator, if it's the same as this or this or this, we can choose it, because it should be constant or coefficient, or maybe a base also in some cases. So let's use the calculator. 18, right? 18, 1.16. Okay, 1.16, and then 1.4 to the power of 2. The answer is this number, which is not given. 40.9 is not given in the question. But what the second one, 18, 1.4 to the power of 0 plus 4. 0 plus 4 is 4. So this is 4. And we don't have 1.16. So we just cancel this. 18 times 1.4 to the power of 0 plus 4. We explained, we replaced x by 0. So the answer is this number, which is not the same, not given here. So none of them gives the answer. So we can just replace x by 0 in both of these answers, and you will not get the answer as 1 of 18 or 1.16 or 1.4. So none of them is the answer. This is how to deal with this kind of questions. I hope you understand this. I hope you get something from this lesson, and I will see you in the next videos. Thank you very much. See you later. Bye.